Okay. So we derived the expression for a bending equation, a flexural equation, okay, for a beam in the last class. So next today we'll solve the problems on that. So before going to the problem, you need to know the equation for section modulus for various cross sections. So it may be circular, rectangular or hollow cylinder. Okay. So what do you mean by section modulus? We have is equal to m by I is equal to y, right? M by I was equal to sigma by y. In that, we call that I by y, the ratio of I by y, that is, section modulus is defined as the ratio of moment of inertia, the ratio of moment of inertia of that section about neutral axis to the distance to the outer fiber. The y maximum we call it as distance to the outer fiber, distance from neutral axis to the outer fiber. So this ratio we call it as section modulus Z. It is denoted by Z. So basically, you should note down these equations for rectangular cross section. For a rectangular cross section, the section modulus. So this is the rectangular cross section. It is having a symmetry. The neutral axis will be at the center, exactly at the center. If you take this width as depth as d, small d, and width as b, small b, the neutral axis will be exactly at the distance d by 2. Neutral axis will be at a distance d by 2, right? So what is that section modulus? Section modulus, it is defined as the ratio of moment of inertia to a distance from outer fiber to neutral axis. The distance from outer fiber to neutral axis, we call it as y maximum. So you need to know the expression for z for a rectangular cross section. So you need to remember this to solve the problems. I, for a rectangular cross section, moment of inertia, it is given by 1 by 12 BD cube, B into D cube. You need to know this. So at certain point, you need to know this also. So just note down the equations for with respect to particular cross section. For a rectangular cross section, moment of inertia is 112 BD maximum. Depends on Y maximum. So here for this rectangular cross section, Y maximum is distance from neutral axis to the outer fiber. That is the maximum distance. So if the neutral axis for this section, it is exactly in the center. If you take to the outer fiber to the above or below, the distance will be same. So you can take to one of the sides. So Y maximum is d by 2 from the sketch. From neutral axis to outer layer, it is d by 2. So, right? So now you substitute that in the section modulus equation I by y maximum, you will get z as bd square by 6. So better note down these three equations. Equation for moment of inertia. So you should know this sketch. Then section modulus, it is defined as ratio of moment of inertia to distance from outer fiber to neutral axis. There is a maximum distance. So Z for rectangular cross section, it is BD square by 6. So better note down, you need this for solving the problem. So note down moment of inertia equation and what is Z for rectangular cross section. Next, for a hollow rectangular cross section, if there is a pocket like surface that is a hollow rectangular cross section, the outer width it is capital B, the inner width for the rectangle is B, and the depth is a small d. Then same thing, the moment of inertia it was 1 by 12 BD cube for a solid rectangle. So here for a hollow it is the bigger size outer, it is BD cube by 12 minus the smaller one, inner side, it is BD cube by 12. So if you can remember this, you can write that equation for hollow rectangular cross section for moment of inertia. Then D is distance from neutral axis to the outermost fiber. Outermost fiber, the maximum distance, that is y maximum. Y maximum is distance from neutral axis to the outermost fiber of the section. This is the neutral axis will be at the exactly center. So y maximum will be d by 2. So z is defined as I by y. When you substitute these two in this section modulus, z is minus dq by d. You need to remember this equation also. Or if you can know this, you can write the equation for halo. And okay, next is a circular section. Circular section. Solid circular section. The neutral axis is also exactly at the center. Since it is a symmetrical section, for a symmetrical section, it will be at a center. So then, for a solid circular section, moment of inertia, it is given by pi d for 4 by 64 equation. Remember, then y maximum is distance from neutral axis to outermost fiber. Its diameter is d. So from neutral to outermost, it is d by 2. D by 2 or r radius. So section modulus, it is I by y, it is pi d cube by 32 for a circular cross section. Circular cross section, it is pi d cube by 32. Note down. Similarly, for a halo shaft or halo rectangular section, we will be having two diameters. There is one is the inner diameter and outer diameter. Outer is capital D, inner is small d. Similarly, the distance from neutral to outermost fiber, it is d by 2. It is d by 2, this distance from center to outermost fiber. The same thing, moment of inertia, it is same as the previous one. It is pi d cube by pi d power 4 by 64 for a solid. For a halo, it is outer diameter minus inner diameter. The extreme fiber distance y maximum is d by 2. So extreme fiber distance, moment of inertia, the ratio will get you the section modulus. That is pi by 32, d power 4 minus d power 4 by d. So note down these equations. So if you can remember for solid section, you can write it for halo section. So the last one, it is for triangular section. For a triangular section, you know that the distance from a larger, smaller end to the neutral axis, or this is center of gravity or neutral axis here. It is 2 by 3. All the problems in beams. Then from this end, it will be 1 by 3. The distance will be 1 by 3 from this end, the height. Okay, here the neutral axis will be there. This distance will be 1 by 3. So we are going to take y maximum. It is y maximum. The maximum distance from neutral axis to outer fiber. From here to here, the distance is 2 by 3. It is higher when compared to from this end to this end. It is not shown here. It will be 1 by 3 times h, this distance. Okay, so we need to consider the ratio of it is. So we are going to consider this maximum. For triangle, it is bh cube by 36. So z will be bh to the square, bh square by 24 for triangular section. So note down for all the three. Then we'll move on to the problems. So if you want to take down, you can take it. Note down in your book. So we'll move on to problems. So it is just for your understanding. They'll not ask anything. You need to know these equations to solve the problem. So for triangular section, I think you have taken for halo cylinder. For you just take it for solid cylinder, you can write it for halo. So solid, it is moment of inertia. So y maximum, you will be knowing it is distance from neutral axis to the outer fiber. This can be by looking at the sketch, you can note down this. But remember these equations. Moment of inertia. So when you can remember this y maximum for any of the cross section by looking at the sketch. So you will be knowing the z section modulus equation. When you substitute, you can write the equation for z. Okay, and rectangular section. Just if you can know moment of inertia, you can write the equation for Z. Okay, note down the first problem. Okay, note down this problem. Problems on bending and shear force in beams. The steel plate of width 120 mm and thickness 20 mm is bent into a circular arc of radius 10 meter. You need to find the maximum stress induced bending moment also. Okay, it is a steel plate of width and thickness. It is given. So it is nothing but a rectangular cross section, right? It is a rectangular cross section. So you need to know the rectangular cross section details to solve the problem. So moment of inertia it is 1 by 12 BD cube by 12. So this width is given and this thickness of the cross section is given. Width of beam, then thickness. Thickness for the beam or thickness of beam is given. So width will taken as in, so give some notation. Width is B, small b. Thickness has D or depth. Thickness or depth, small d. So what is the
120.
1 to 0? 1 to 0. Depth for the beam is given.
20.
2 0,
20.
20. Okay, it is then you should know it is a rectangular cross section. It is a rectangular cross section. Then it is bent into a circular arc. It is bent into a circular arc. This beam is bent into an arc. So when it is bent, there will be an arc radius. That radius is given, right? The radius of curvature. We call it as the radius of curvature. So we have derived the expression R. M by I is equal to sigma by y is equal to E by R. So that radius of curvature R is given. How much? 10 meters. It is in meter. We convert this to mm. So keep all the units in single unit. So it is R is 10 into 1000. So it is 10,000 mm. So meter to mm. Next, at last they are given take modulus for the material, that is E. Young's modulus. It is how much? 2 into 10 to the power of 5 Newton per mm square. So these are the given thing. You need to determine the maximum stress and bending moment. It is induced in the beam. Maximum stress, that is sigma, you need to find, and bending moment. Right. So what is the equation that we derived? That is m by I is equal to E by R or sigma by Y is equal to sigma by Y. Right. This is the equation what we derived in the last class for a bending stress equation with respect to beam or flexural equation for a beam. So we just make use of this equation. You need to know this equation to solve the problem. So first, what I need to find what bending moment that is induced in the beam. The moment which is induced in the beam and stress induced in the beam has to be found. So look at the given data. Look at the given data. So what all the things are given and what you need to find, you find. You decide. Okay. It is a rectangular cross section. It is a rectangular cross section. The neutral axis will be exactly at the center for a rectangular cross section. Okay. So this width is, what is this? What is this height? How much? This is thickness or depth. So this is the width. Width is B. Right? So now let me take some combination. So what is the moment of inertia for, so if I want to find M, there is E. Modulus is given in the problem. Radius of curvature is also given. So I can use this combination, that is E by R is equal to M by I. Right? So M is not known and I also not known. So what is the moment of inertia for a rectangular cross section? The moment of inertia for a rectangular cross section. You need to remember this. Right? Keep it in. So it is I is given by BD cube by 12 for a rectangular cross section. Then what is Y maximum? Y maximum is D by 2. So that is BD square by 6. You need to know these equations. Moment of inertia, that is I is equal to BD cube by 12. Calculate. So what is D? D is known. B is also known. We calculate I. So once you get I can use these two combinations. M by I is equal to E by R, and I can find M. Right? So then afterwards I can use these two combinations. E by R is equal to sigma by Y. Then I can find sigma. So what is Y? Y is nothing but Y maximum you need to take. Y maximum. So what is I you find?
80,000.
80,000. Okay, 80,000. So I is or 8 into 10 to the power of 4 unit. It is mm to the power of 4. It is b cube into b. It is mm to the power of 4. Okay, next. So find the moment next. The bending moment. To find the bending moment. That is, use these two combination. M by I is equal to E by R from the equation what we derived. So that is M by I is equal to E by R, or M is equal to E by R into I. So we know all the terms, calculate the bending moment. Okay, these are direct problems. I'll be doing it for one. So if it is given for hollow section, you need to know the equation for hollow rectangle. If it is solid circular, you need to know the equation for solid circular with respect to moment of inertia. And if it is hollow circular, you need to know the moment of inertia for hollow circular beams. So this is M, so direct substitution. E you know, R also is known. So make sure all the units are in same units. So if you're following meters, take it in meters. If it is in mm, all the units to be in mm. What is M?
16 into 10 power 5.
Moment is how much? So direct substitution, you find it. You get it in Newton?
6.
Mm. How much? 6?
16 into 10 power 5.
Yeah, it is 16 into 10 power 5. So next, you find the maximum stress that is induced, that is sigma unit to find. Now we will use these two combinations, that is E by R is equal to sigma by Y max. That is Y is nothing but Y maximum. You need to take the maximum distance from the neutral axis to the outermost layer. So it is the neutral axis is here. The outermost distance, it is how much? It is D by 2. So let us consider E by R is equal to sigma by Y maximum or Y, both are same. So that is Y maximum is D by 2. It is D by 2. It is total distance from neutral axis to the outermost layer. It is, this distance is D by 2. So D is how much? It is 20, Y is 10. So it is equal to 10 mm. So now you find sigma. Sigma is equal to E by R into Y maximum. So what is this bending stress?
200.
200 Newton units. Newton per mm square. Okay. So these are direct problems. So if anything is given with respect to a circular cross section or hollow circular or a hollow rectangle, you need to use for hollow rectangle the moment of inertia equation. This I'm not going to solve. So you need to be using this. Okay. So next I will move on to next type of problem. So y maximum will remain same. So if it is circular section, the moment of inertia is pi d power 4 by 64. Okay. If it is hollow circular, then it will be this quantity. Okay. So next, note on the next problem. Solve the problems here. You need to know the equations what we derived in the first part of this module 3. So that is equation with respect to simply supported beams, cantilever or any forms of the beams with respect to supports. The maximum bending equation has to be known. You need to know that to solve the problems here. So here, second problem, you need to use those maximum moment equations. So here a square beam is given, 20 into 20 square beam, and length is given, it is supported at the ends. End supports in the sense it is a simply supported beam. The beam fails when a point load applied on the beam at the center, exactly at the center. So that is the first part of your problem. Next, what uniformly distributed load for a same this thing. So what is the load for uniformly distributed? If the uniformly distributed load per meter will be breaking per meter length will break a cantilever beam. So for the same load, if the beam is of cantilever type, you need to find the load. The first part they are given it is a simply supported beam with some applied load at the center. Okay. For that beam, you need to find out the stress induced due to that applied load. Maximum stress induced. So next part, if the beam is of same material, if the beam is of same material, if it is of same material, the maximum stress will be same. Then, if the load applied is uniformly distributed load and the beam type it is cantilever beam, read the problem statement correctly. Here, in the first part they are given, it has a simply supported beam. Okay, there is some beam. So I think you have finished the problem. Let me start with this. So it is of two different problems. Up to first sentence, first paragraph, it is first type of problem. One problem, it is on simply supported beam. So next part of the problem, it is a problem on a cantilever beam with uniformly varying load. Okay. So here what they are given, a square beam of 20 by 20. So first part is a square beam. It is width of beam and depth of beam. So if it is a square beam, ಎರಡು same ಇರುತ್ತೆ, right? So width is B, B is 20 mm, then depth is our length of beam, that is L, is 2 meters, 2 meter, right? Or 2 into 1000, or 2000 mm. Convert meter to mm. Then point, it is acted with a load W at the ends. It is given, it is acted with a load. There is a beam here. It is supported at the ends. It is supported at the ends in the sense it is a simply supported beam. So, and the load, so this beam length is L, and load is acting exactly at the center of the beam at a distance. So this distance is L by 2 at a center, at the center. So the load acted, it is how much? It is 400 Newton. So load is W, W is 400 Newton. So this is the first part of the problem. In the second part, so this beam material, that is AB, if AB is the beam, so this AB will remain the same in the second part, but it is acted with cantilever supports and uniformly distributed load. So then you need to find the W. That is supported beam with central point load. So here you need to know, here any type of the problem can be given. So we have derived the equation for cantilever beam with respect to UDL, varying load, point load. Simply supported beam as UDL, varying and point load. You need to know the equations for maximum moment. The maximum moment, M max equation should be known for all the beams. So that, as I told, whatever the equations are available, that you need to note it on some page so that you can memorize that. So it will be helpful here. Directly you can take it. So what is the maximum moment for a point load? Somebody has written, and turn your page, you can find it. So what is the derivation what we have done? So maximum moment M is how much? M max. Or you can look at the moment diagram. In the moment diagram, it will be represented. It is WL by 4 for point load with cantilever beam at the central point load. So okay, we will just move on to this problem. Other parts will remain same as the last problem. Other things will remain same as last problem. Okay. The same thing. So what is that equation we had? M by I. So here I need to find the, here I need to find a maximum stress acting on the beam due to this load. We'll find a stress sigma that is acting on the beam due to the applied load. We have the equation M by I is equal to what? Sigma by Y, right? M by I is equal to sigma by Y. Or we take, okay, by bending equation, that is M by I is equal to sigma by Y. This is for the derivation. That is also equal to E by R. Here, let me consider these two. So here, what is M? or sigma. Or sigma is equal to, so I need to find sigma, the maximum stress induced on the beam. Or sigma is equal to m by, so this goes to this or y by I. I can take this y below this, below the denominator. So this y is nothing but y maximum or y maximum. So what is this term? I by y maximum. I by y maximum is what?
Z.
Yeah, it is z. So in the today's class we discussed this. So this is nothing but a section modulus. So z is I by y, I by y, right? So sigma is nothing but m by z. So what is Z for a circular? So this beam is of square cross section. Square is nothing but rectangular. It is same. Equations will not change for square and rectangular cross sections. So what is Z? So or you can separately find it moment and so you cannot remember. Or if you can remember Z, the Z for rectangular cross section it is given by BD square by 6. BD square by 6. Or you can remember I and Y maximum and you can divide, you will get Z. Both are. Whichever you can do that. So it is M by BD square by 6 for a rectangular cross section. Or rectangular or circular. This is a square cross section. Square cross section. Right? So what is M? M is a maximum moment. Here M is M max. M is M max. It is a moment with respect to a type of the beam with support and load. For a simply supported beam, or simply, so these things you have already done. You can turn out your pages, derive the equation for simply supported beam with center or central point load. Maximum moment is given by what? M max is equal to WL by 4. It is given by WL by 4. These things also has to be remembered. So these things has already done. In the first part of module 3, we have derived the equations, that is bending moment and shear force diagram. In the bending moment diagram, you can see this. The maximum moment value, it is WL by 4 for simply supported beam with central point load. So this thing is already done. So you need to remember this from there and you substitute for M max. So M max is that quantity. So sigma will be equal to W L by 4 divided by BD square by 6. So BD, I know, L, I know, W is known. So all the quantities are known. You will get directly the maximum stress acting on the, so that is sigma maximum. This is the maximum stress with respect to the moment, maximum moment, sigma maximum. Find out. So any form of the beam can be asked. With respect, we have derived the expression for maximum moment. So you should remember those equations. So here it is with respect to point load with at the center. You look at the bending moment diagram. There we have written this with on the moment diagram. So it can be a cantilever beam with end load. So there you should know the moment equation is W into L, the maximum moment equation. So note down those moment equations first. So unless you cannot solve problems here. So you need to know the equations what we have derived already.
One 1.5 into 10 to the power of 2.
Sigma maximum is ಅಲ್ಲ ಇದು W is by
2
4n.
into 10 to the power of 5.
Into 10 to the power of 5. Check all the units is in right?
Yes.
One.
Yes, sir,
150, na?
150.
Yeah, 150 is right. It is 150. Sigma maximum is 150 Newton per mm square. So the problems here, it will be simple. The only thing you should know the maximum moment equation for all the type of loads with respect to support. So note down that in one sheet. So in the from first chapter, I'm telling whatever the equation comes, you note down with respect to that particular chapter. Unless this subject cannot be easier. So if you okay. This is the maximum stress with respect to the first part, what it is given. With respect to when the beam is simply supported and load is 400, the stress induced for the applied load is this much. So, okay. So this is the maximum stress that the beam can withstand. So I'll quote at this particular load, the beam fails, so that at that maximum load, the maximum stress the beam can withstand is only this quantity. It is 150. Okay, next part of the problem, what it is given for a same beam material, that is AB remains same. Then for a same beam material, if the beam is if the beam is cantilever beam with UDL so this is W per meter length. This W per meter length. If the beam is acted with, if the same beam AB is supported with, instead of simply supported, it is a cantilever support with UDL. What is that statement? With UDL, with uniform distributed load per meter length, uh, will break a cantilever beam for a same material 40 mm wide, but beam cross section is different. If for a same material, if this cross section of the beam is, so if this is 40, 40 by 60, I think, right? Width and depth. If it is 40 and 60 and length of the beam is 3 meter, the length of the beam is 3 meters. This is 3 meters. You need to find the load W. So what is the load that is acting on the beam? That has to be found. So here, since it is of same material, the material properties does not change, so that the maximum stress that the beam can withstand with respect to maximum load will remain the same. So this maximum, sigma maximum will remain same for this particular beam also. So using this sigma maximum, you need to W. So here for the second part, so what is the width of the beam and what is the depth, length? So width of the beam it is given as 40 mm wide and 60 mm deep and 3 meter long. Okay, it is so width B will be 40 mm, depth will be 60 mm, length is 3 meter and it is 3000 mm. Okay. So now the cross section, it is rectangular type cross section. Rectangle type, right? So it is, there is the neutral axis. So this will be D and B. Okay. So now same thing, find out the maximum moment first for that beam. A maximum moment. So we have done this derivation for a UDL cantilever with UDL. So if anybody has written, you can turn your page. What is the maximum moment for cantilever beam with uniformly distributed load? Maximum moment sigma, that is M max, is given by WL square by 2. The maximum moment is for a cantilever beam, it is WL square by 2 with UDL, with uniformly distributed load. Right? So what is maximum moment you calculate? The same expression. Here also nothing is different. Here I need to find W. W is the unknown. You will get in terms of W, you find.
Minus W.
How much? WL square by 2, you will get answer in terms of W. So ಇಲ್ಲಿ W, it is per meter length ಅಂತ ಇದೆ load. So what is M? How much? For the second part of the problem. Three thousand square by 2. How much? So these equations you need to remember. So this is maximum moment for a cantilever beam with uniformly distributed load. So
45
what
into
is
10
that?
to the power of 5.
45. So ಇಲ್ಲಿ 45 into 10 power 5. So here, since W is in W per meter length, W is in W per meter length. So you just substitute L in meter itself. ಆಯ್ತಾ? L in meter substitute ಮಾಡಿ, you will get some answer in meters. So when L is in meters, it is how much? 3 meters. 3 square by 2. It is 9 by 2. It will be
4.5.
4.5. This will be in meters. This will be in meters. Then convert this to mm. This is in meters. This is in meters. So convert this to mm. So m max will be into 1000. So it is 45 into w. It is in terms of mm into 1000. Right? Into 1000 in terms of Newton mm. Since w is in Newton meter, Newton per meter length. So let us substitute in meter itself at first. Then convert that to into 1000. Or ಇಲ್ಲೇ into 1000 ಮಾಡಿ divide ಮಾಡಿದ್ರು ಆಗುತ್ತೆ. Okay. So just be careful here. Since W is not known, it is in meter per meter length ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. So you should also convert W to mm. Okay. So next, find out same equation m by or same equation. Sigma maximum is equal to same m maximum by bd square by 6. It does not change. The moment equations for so substitute here. So sigma maximum is what? We already found this from the previous. It is same 150. So now I need to find what W. So you substitute here and find out W. Sigma maximum ಗೊತ್ತಿದೆ 150. M maximum is 44,500 W. BD are known. BD is given. Find out W. You can write some sentence. Since the material of the beam for cantilever and simply supported beam is same, sigma maximum will remain same. Since it is same material, sigma maximum will remain same. So sigma maximum is 150. Substitute here from the previous simply supported. And find out the unknown will be in terms of W and find out W. How much? How much load per meter length it is acting?
800.
Direct substitute, or if you want, you can find out Z separately and you can find out. So separately section models also can be found and you can substitute here. Or directly you can write the equation and write. It is 800 Newton per meter length. Newton per meter length. Okay. So any form, the shape it is rectangle, it can be given with circular or hollow rectangle. So I'm not solved the problems on this. So there is an equation that already explained. You need to remember those equations with respect to given cross section, right? And for all the beams, you should know the maximum equation. So kindly note down the equations for maximum bending moment. So such that you can solve the problems here. Okay. So, anyway, we'll stop at this point. We'll continue.